All right, so today we're going to talk about solving more logarithmic equations and get to the point where we can solve absolutely any logarithmic equation or exponential equation that we might come across. We talked about last time how to condense several logarithms that were being added, subtracted, that kind of thing, down into one. And that's going to be very helpful for us solving the rest of these logarithmic equations. All right, so things to keep in mind. The first thing is, when we're solving logarithmic equations, we've got two choices. And we can either, basically what we're trying to say here is we can switch them or drop them. What we mean by switch them or drop them is we have already seen that if you have two of the same logarithm, if you have the same logarithm on each side of the equal sign, as long as they have the same base, you can just drop them, right, and solve whatever the arguments are equal to. Same thing for exponential equations. If the exponent bases are the same, then we just drop them and set the exponents equal to each other and solve from there. So if we have the same bases on each side of the equal sign, whether it's an exponential base or logarithmic base, then we just drop them and solve what's left. Okay? However, if we do not have the same logarithm base on both sides, so for example this, we don't have the same logarithm on either side of the equal sign, then we can't drop them. So what we're going to do is we're going to switch them. In other words, I want to go from a logarithmic equation to an exponential equation. Remember, base stays base, and the other two play switcheroo, and so now I want to go try to solve that, which I actually can. Okay? So that's what we're going to talk about. We're going to talk about either switching them or dropping them, depending on what we can do. Okay? Remember that the base of the common log is 10. Right? We don't want to forget that. And then remember our properties. This is what I was talking about before, condensing down into one logarithm when we have several, right? Addition always led to multiplication, so we could rewrite this down to one logarithm by taking those arguments and multiplying them. And then for subtraction, that always led to division, as long as the first argument went in the numerator and the second argument went in the denominator. And that's going to be helpful because we only want one logarithm on either side of the equal sign. So we're going to want to condense down. Okay? This is not different than you know. So this last reminder is that we cannot have negative logarithms. We cannot take the logarithm of a negative. That always leads to extraneous solutions, things that we want to make sure that we're looking at. Okay? All right. So some quick warm-up, some reminders from what we did last time. Go ahead, stop the video, try to condense these down into one logarithm. Starting back up, I'll walk you through it. All right, so the first one, if we want to condense down to one logarithm, addition leads to multiplication, so 3 times x is 3x, we just get log base 10 of 3x. Subtraction leads to division, so we go log base 2 of 22 over x. The first argument goes in the numerator, second argument goes in the denominator. Last but not least, the third one, we have to remember that coefficients can be rewritten as exponents, right? So this 5 we can bring up as a coefficient on that x. So log of x to the 5th, excuse me, plus log of x plus 2 minus log of 4. And then we go left to right, right? For addition, we rewrite as multiplication. So we go log of x to the 5th times x plus 2. Minus log 4, and then subtraction we can rewrite as division. And so the 4 would go into the denominator of that division problem inside the logarithm. Okay? All right. And then change a base. We want to remember how to work change a base. Right? Remember, in your calculator, if we want to evaluate log base 81 of 27, then we take the log of 27, log base 10 of 27, because that log button is in your calculator, and divide it by log of 81. Right? And get that value. And get 0.75. Right? All right. Again, should be able to do these two problems, so stop the video, give it a shot, start the video back up, and see how much you remember. Okay, so did you remember in the second one, in this exponential equation, you want to get the exponent base by itself, so subtract 6, get 10 to the x equals 894. So this is what I'm talking about with either switching them or dropping them. Since we don't have the same exponent base on both sides, and we can't make the same exponent base on both sides, we want to switch the form and turn this from exponential form into logarithmic form, make this log base 10 of 894 equals x, and now you can use your calculator to evaluate this, which is 2.95. Same thing for the last one, add 8, get 9 to the x plus 4 equals 80. I cannot create the same exponent base on the right side, so switch it. Log base 9 of 80 equals x plus 4. So we need to evaluate that logarithm and then subtract 4 to solve for x. So we take log base 80 divided by log base 9. Remember, change a base. And then subtract 4 from that value. And we get negative 2.01. Okay? All right. Now, same thing goes for logarithmic equations. If we cannot or do not have the same logarithm base on both sides of the equal sign, then we just switch it to exponential, right? If we do have the same log bases on both sides, we just drop them. Right, so for example here, we do not have log base 10 on the right side of the equal sign, so we've got to switch this to exponential form. So base stays base, the base of that log is 10, so you get 10 squared equals 4x minus 3. 10 squared, of course, is 100. Now we're going to add 3, divide by 4, and x is 103 over 4. Or if you want to divide it out and get a decimal, you certainly could do that. You get 25.75, but we do want to make sure that whatever we get for our solution does not make the logarithm negative. It won't, so we're good here, right? Number 2, same deal, right? We have a log base 3 on the left side, but not a log base 3 on the right side to just drop them. So we've got to rewrite this in exponential form. Base stays base, the other two place switcheroo. We get this, 3 cubed is 27. Now subtract 5, divide by 2, and x is 11. Okay? Now, here, we do not have the same log base on both sides of the equal sign. I know we have these guys that have the same logarithm base, but they have to be on opposite sides of the equal sign before we're allowed to drop them. We can't drop this guy here. So instead, we can condense down to one logarithm, and we need to. We're only allowed to have one logarithm on either side of the equal sign. So we've got to condense down to one logarithm, right? So addition leads to multiplication. So we got to make this log of x times x minus 3. Okay, now we still cannot drop the logarithm because there's not one on the other side of the equal sign. So we do a little switcheroo here. So 10 to the first equals x times x minus 3, and then we solve, and we have a quadratic equation. Got to get it equal to 0, so subtract the 10. and then we factor and solve. So this is going to be x minus 5 and x plus 3. Our two solutions become 5 and negative 3. Now you've got to be careful. 5, if we plug into the original equation for x, does not give us the negative logarithm, but the negative 3 would, right here. Well, and right here. So we can't use it. Negative 3 becomes an extraneous solution. We really ought to list it. So we can't use it. X equals 5 is the only solution. Okay? All right. So same thing here with 4. You want to condense down to one logarithm on the left side here. So we go log base 2, and we have to use multiplication because we're adding there. We do not have the same log base on either side of the equal sign, so we switch this over to exponential form. 2 cubed is 8. This is another quadratic, so subtract 8 from both sides. Factor and solve. We factor into x minus 8 and x plus 1, and the two solutions are 8 and negative 1. But if we were to plug negative 1 in for x, then negative 1 is would create a negative logarithm, so negative 1 is an extraneous solution. We can't use it, so 8 is our only solution. Okay? All right. Take a second and try this guy. Stop the video, condense the logarithms into one, and then solve from there. You can start the video back up and see how you're doing. Okay. Did you condense this down into using multiplication, log base 2 of 3x? Then we go into exponential form because there's not a logarithm on both sides. This is 16. We divide by 3. And x is 16 over 3. Okay? All right. Now, same thing here, only now we've got subtraction. And so what we're going to end up creating is a fraction. When we condense down, right, subtraction leads to division. So we go 5 divided by 2x. And we still have the same problem as before when we do not have the same logarithm on the right side. So we've got to switch this to exponential form. 10 to the first equals 5 over 2x. How you choose to solve for x here is entirely up to you. I highly recommend that you make this side a fraction so that you can cross multiply and solve. Multiply 5 times 1 and get 5. 10 to the first, of course, is 10. 10 times 2x is 20x. Then divide both sides by 20. And x is 1/4. Okay? Same deal here. Right? We've got two logarithms on the left side, and so we want to condense down to one. So we go log base 3 of 56 over x equals log base 3 of 7. Now, we do have the same logarithm base on either side of the equal sign, so we're allowed to just drop this and solve for 56 over x equals 7. Again, I would put the 7 in as a fraction so that we can cross multiply, get 7x equals 56, divide both sides by 7, and x ends up being 8. A quick look at the original equation. 8 will not give us a negative logarithm, so we can use it as a solution. I forgot to check the last problem, so make sure that you're checking everyone. Okay? All right. We're going to find the same situation here. We want to condense these two down using multiplication since we're adding the two logarithms. So 2x times x minus 3. And then we recognize that we have the same logarithm on both sides of the equation, so we can drop those logarithms, distribute that 2x, and solve this. Subtract the 8 from both sides. Factor out a GCF. Now we're into factor mode. Factor this trinomial into x minus 4, x plus 1. And then if you were to set each factor equal to 0, that would include 2, but 2 equals 0 does not give you a solution. Set these guys equal to 0, and you would get 4 and negative 1. A quick look to the top shows us that negative 1 would make both of these logarithms negative. So negative 1 is an extraneous solution. We can't use it. X equals 4 is our only solution. Okay? So some of these are going to take some steps, right? Just look to see if you can condense down logarithms, and then look to see if you have the same log base on both sides of the equal sign, like number 9 right here. We can just drop these logarithms, set the arguments equal to each other, and solve for x. Add 3x, divide by negative 2, x is negative 5. Now you start to think, wait a minute, we've not been able to use the negative solutions before, so we probably can't use negative 5 here either. But if you look, if you plug in negative 5 for x, this becomes positive 25. And right here, you're going to get 10 plus 15, which again is a positive 25. So you don't get a negative logarithm when you plug it in. That means we can use negative 5. Negative 5 is fine. It's only if you get a negative logarithm when you plug it in that you have to be careful. Okay? All right. Number 10, we've seen before, right? We cannot rewrite 21 as a base 5 to a power to make the bases the same. So since the bases cannot be the same on both sides of the equal sign, we want to switch the form. That means from exponential form to logarithmic form. So log base 5 of 21 equals x. Here we can use our change of base formula to evaluate the logarithm. Log of 21 divided by log of 5. As I type this in, feel free to do the same thing and see if you end up getting what I get, which is 1.89. Okay, make sure you get that. If you don't, you need to get in and get some help. Okay, number 11. Same deal. We cannot rewrite 17 as base 3 to a power to make the bases the same and drop them. So we got to rewrite log base 3 of 17 is equal to x minus 4. We've seen these before. Evaluate the logarithm. Log of 17 divided by log of 3. And then we got to add 4 to both sides. And so you should get 6.58. Okay. All right. Number 12, we've got a problem. We do not have, the exponential base on the left side is not by itself. So we've got to get it by itself by subtracting 6. Get 10 to the negative 12x equals 994. What? 994? How about just 94? We have to switch it because we don't have the same exponent base on both sides. So log base 10 of 94 equals negative 12x. Now we can just take log of 94 in our calculator, divide by negative 12, and x ends up being negative 0.16. All right? All right, these next several are just more practice for you. So stop the video for each one. I'll start it up and show you the work so you can check it. And if you're not getting these, that tells you that you need to come in and get some more clarification. Okay? So go ahead and start with this one. Stop the video, start it back up, and see if you get the same thing. Okay, so you should have gotten 10. Condense down the two logarithms, rewrite in exponential form. You do get plus or minus 10 when you square root both sides, but the negative is going to be extraneous. Try this one. you should get x equals 2, which is not going to be extraneous. It's a perfectly fine solution. And you can see the work there. Okay? All right, try this one. Stop the video. Did you get x equals 3/4 or 0.75? Hopefully you did. Feel free to stop the video and see the work there to check yours if you did not get 3/4. Okay? Otherwise, try this one. And x should be 59. See the work there? If you can't figure out what happened if you didn't get 59, again, come in and see me. We'll figure it out. All right, try this one. Okay, should have gotten 1.32. Just using the change of base. Okay, all right, let's try this one. X is 4/3. Combine your logarithms down to 1, rewrite in exponential form, and solve from there. Again, feel free to stop the video and check out the work to make sure you can figure out what happened to in your problem if you did not get 4/3. Okay? Otherwise, that's it. Homework's out in Canvas. Make sure you have that done by next time.